This is topic 9.2, absolutely entropy and entropy change. Learning objective, calculate the entropy change for a chemical or physical process based on the absolute entropies of the species involved in the process. So we have an equation we're going to be dealing with today, and we'll go over how to use it. And for the most part, you'll see that it's actually fairly easy to use. So you should be happy with this one because once you get the hang of it, it should make sense. Entropy or delta S can be described both qualitatively and quantitatively. So in definition, entropy is the measure of disorder of a system, like we kind of mentioned before. So in this qualitative description, if you will, we know we're able to tell how if something there's an increase or decrease in entropy qualitatively. However, looking at it quantitatively, we have to be able to calculate. And the second law of thermodynamics states that the entropy of the universe increases in a spontaneous process and remains unchanged when a system is at equilibrium. So if we're in a spontaneous process, entropy in the universe, delta S, equals delta S system plus delta S surroundings, and this is greater than 0. If we are at equilibrium, this is going to be equal to 0 instead. So let's focus on the entropy of a system. So we calculate the delta S of a system, delta S system, which is the same as delta S reaction, by adding the standard entropies for the products multiplied by their coefficients, and then repeating that process for the reactants, and then subtracting products minus the reactants. So this should be on your list of formulas, so hopefully it is. So if the reaction is coefficient A plus coefficient B producing coefficient C plus coefficient D, the delta S of the reaction, all you're going to do is you are going to multiply the coefficient by the delta S of the reaction that it's given to you. You're going to add those up for the products and then subtract that from the subtract from the products, you subtract the reactants. So these values are you're going to use, they're going to give it to you. They're not going to expect you to memorize them. You just have to know how to use them correctly. So using the thermodynamic data, calculate the delta S for the following reaction: 4NH3 plus 7O2 producing 4NO2 plus 6H2O. So the delta S of the reaction is the sum of the delta S of the products minus the sum of the delta S of the reactants. So this equals 4 moles of NO2 times 240.1 joules per mole times Kelvin. So we just look at that. I didn't really describe this, but you need to look at your compounds and then make sure that you plug it in correctly. Plus 6 moles of H2O times 188.8 joules per mole Kelvin minus 4 moles NH3 times 192.8 joules per mole times Kelvin plus 7 moles of O2, 205.2 joules per mole Kelvin, brackets, and this is going to equal approximately negative 144.4 joules per mole times Kelvin. All right, using the provided thermodynamic data, calculate the delta S of the following reaction. You have a general reaction, so 2A2B2 plus C2A4 producing C2 plus 4A2B. So they give you the units. They give you your standard entropies, and then from there you can determine the delta S of the following reaction. So remember, delta S of the reaction equals the sum of delta S of the products minus the sum of the delta S of the reactant. Sorry, I should have said reaction earlier. So same concept. Luckily, the numbers aren't as big as the previous example. So this equals the sum of the products. So it's going to be 1 mole times 191.6 joules per mole times Kelvin plus 4 mole of A2B. So this is going to be 188.1 joules over mole times Kelvin, bracket minus, same concept for the product, for reactant side, I'm sorry. So 2 mole times 109.6 joule over mole Kelvin plus the other reactant, 1 mole, and this is going to be for C2A4, 121.1 joule over mole Kelvin. So we're going to have to, as I'm going to finish this up, something we need to think about is how can they try to trick you? What are some ways that they're going to try to kind of mess with you a little bit? What are some things that they can do, or what are some things you need to think about? The answer is 603.7 joule per Kelvin. So as you're doing this, and you're reviewing for your exam, think about how they can kind of change things up a little bit, how they may not try to mess with you, but make sure you guys know what you're doing. So that's something to think about. If you have any questions, please let me know. Thanks.